Okay, welcome to this basic TDD basically writing Python tests. I noticed a number of you have been having trouble with tests, so I sort of like created this simple basic intro to just to walk you through the basics. Okay, so let's begin. Okay, before we go any further, there's this resource here. I'm going to share the link in the description. Okay, it talks about the basics. So in Python we have the unit tests. We have this unit test stand, which is part of the Python standard library. So this is what I'll be talking about, and then I'll also down the road I'll also talk about a few tools like this pytest. Now the unit tests. Okay, the unit test module comes. It comes embedded. It comes along with a. It comes with Python. So when you install Python, you already have unit test. You can use it out of the box. Okay, so without further ado, let's dig in. Okay, there's a code snippet here. We are going to copy that. So here it says, in order for when you're creating tests, when you're creating test cases, when you're using unit tests is accomplished by subclassing this unit test.test case. So you create a class here. Here you created a class called myTest, and which inherits from, or as you say, it's a class which inherits from unit test.test case. Yep. Okay, so I've created a module here called test simple mathlib unit test, which we're going to be using since we are going to talk about pytest and unit test. So I deemed it wise to rename these modules, any with pytest and any with unit tests, just to differentiate the two. So ideally we are going to be writing a simple mathematics library which does simple mathematics operations like addition, subtraction, multiplication, and division. So let's paste that little bit of code that we copied from that site, and then we clean it up a bit. So the first line here, you have to import unit tests. Unit test, the unit test module in Python if you're going to use unit tests. And then this class here, he called it my class, but then as you noticed, it uses camel case. Camel case means that if you have two different words, the first letter begins with a capital, and for the first word, and the second word also begins with a capital. Yeah. So as you can see, it had something like my test, my being one word and test being another word, but they are different. So we had to say my with a capital M and test with a capital T. So since we have a simple mathlib, we're going to rename ours to test simple mathlib, which of course subclasses the unit test case. And then here now you start just simply coming up with your test cases. His first test case was called test. Yeah. Okay, so from the basics of object-oriented programming, like if you have a class, so each and every method of this class must take in self as the first argument. Okay, from the basics of object-oriented programming, if you're not very familiar with it, I'm going to give you some resources that you can begin with. So let us first of all test the add method. Yep. Okay, basically we are going to name this to test simple mathlib. Test simple mathlib methods. No, because this simple mathlib is going to house just simple mathematical methods to do mathematical operations. So this first function, it's test. As a general rule, all test cases must begin with a word test. So every method that you're testing must begin with test. So we say test underscore. As you can see, Python uses its if you have two words, join them with an underscore. More called snake case. The snake case way of writing things. Snake case pattern. Syntax. Okay. Not to dwell so much on that. We're going to test the add method. Yeah. So we're going to call it add number. As we said, it will take itself as an argument, and then there are a couple of methods. They are assertion methods. There's assert equal to, there's the raises, there's assert not equal to, a couple of assertion methods, which I'm going to share a link to such resources which have all those assertion methods that come with unit tests, and a whole bunch of other methods that are included in the unit test module. So here we're going to say self.assert. Here it's more like we are saying assert is more like, let's say that it is true. Let's confirm that it's true. Let's affirm that it's true. So we are saying let's assert that add numbers. Of course, add numbers will take in a couple of arguments. Let's say it takes in let's create a couple of arguments here. Let's create something like first number. So create a variable first number and give it a value of 10, and then we'll create a second variable and give it a number of 5. So let's assert that when you add first number and second number, let's assert that the addition of this is actually 15. Yeah. Okay, so that's our first case. So immediately we're going to add more test cases. So let's declare this in our main before we forget. This is just simply just running our module actually. So when we execute this downer part here, this code is the one that the Python interpreter will look at, and then it will run our module. It will run the whole code in our module. It will create a variable called name and assign it. It will create this is called a special variable. It will assign it a name of main, and then it will run whatever the script contains. So in this case, we are just simply going to call unittest.main. This is what we're going to be running. Okay, so down here in terminal, if I do ls to see the number of files that I have, you can see that I have my test Python lib mode. So when I say Python test mathlib unit tests.py, as you can see, it raises an error which says the function that the test that we ran, which I call test add number, and it is found in this class of ours which we called test simple mathlib methods. You'll say that the global name and number is not defined. Like this is not actually defined. It ran one test in 0 and it failed, right? Well, the reason as to why it failed is it's because we actually don't have any code to run against this, so the tests will definitely have to fail. So let's go to our simple mathlib and make sure this test passes. Create our function called add numbers. Add numbers takes in a first number and a second number. So we'll create another variable called total. Create another variable called result, and then we assign it the mathematical operation of add, that's second number, and then we return. Every function must have a return. Every function must actually return something. So every function must have this return statement down here. So return result. Yep. So now this is our function. Now when you go back here and we try to run this, oh, it still fails. Let's see. Oh yeah, it still fails because we're using this. Okay, we need to import that module. We need to import our simple mathlib module, and then in order for us to access this method in the this method right here, in order for us to access this simple method called add number, we need to actually come and we come and say simple mathlib dot. Now dot will be accessing anything. If this was a class, we could actually access a class in this module here, but then we have a method. So in order for us to access a module, in order for us to access a method in this module, which is add number, we write the name of we write the name of the module, which is simple math module, then followed by a period, which is dot, and then we call the add number, add number, not add numbers. So when we go ahead and run our test now, as you can see, our test ran. It says it ran one test and it's okay. So you can execute this with a -v, which is verbose, to see what actually ran. Now you can see it tells us test add number, which is this, which is contained in the test simple math methods, is okay. It ran it and it is okay. Yep, it passed. What I forgot to mention is, you see, since we have only one test case, you see this period here, these periods represent test cases. Since we have only one test case, so it's one period. Okay, so let's go on ahead and then we implement the subtraction. Let us test the subtraction. Subtract numbers. Subtract number. Of course, as I said, since this is contained in a class, it has to take itself as the first argument, followed by any number of arguments that you really want. But right now, we only want it to take in one argument, which is self. So we come and say we do the same thing. Basically, we can copy this whole guy here and we paste him here. Say first number, second number, that we assert. So we are going to call subtract number. Subtract number, which takes into first number, and then we assert that when you actually do a subtraction of 10 and 5, the result is definitely going to be 5. So now we see here it says it ran two tests, but unfortunately we do not have a subtract numbers. As you can see, it raises an error when you come to test subclass, when you come to test the subtract number. Yeah. Now let's go ahead and make this test pass by actually creating that method. Let's copy this. Let's rename this to subtract number, and then we do this. We save that, and then when we go ahead and then we run, it says it ran two tests and they are all okay. Yep, it ran two tests and they are all okay. Here you can see now our test subtract number is now passing. Yep. So let's go on ahead and create the subtract and the multiply numbers. Let's let's do the divide. This is supposed to turn 2, and here we go and do this the multiply. When you multiply this and this, you're supposed to get something like a 50. Of course, this test when ran will of course fail. See, hold on. Okay, so this is multiply and this is divide. Okay, so when you run this test, they will definitely go ahead and raise errors, because right now these methods, the ones that we are testing, they do not exist yet. So these tests are supposed to fail. So let's go on ahead to our simple math lib. I will create those methods. This is the divide number. Instead of a minus, now it will be a slash, and this is the multiply number. So instead of this, we shall make this a multiplication. So let's go on ahead and then run this. As you can see, it ran 4 tests and they all passed. Okay, now right now that is more about TDD. Okay, anyway, our script simple math lib doesn't do anything right now. Let's make sure it does something. Let's make sure. So like I said, we have to create a main for it. So I'm going to have to create a couple of variables here, something like a first number. I'm going to assign the first number to 10, and I'm going to assign the second number to 5. Yeah? Then I'm going to create a couple of variables, say addition, which is going to call my add number, which takes in first number and second number. So I'm going to go ahead and copy this so I can paste it. Paste a couple of times. Now instead of addition, it will be subtraction. So instead of add, it should be subtract number, and it should be division, and it should be divide, and then this is multiplication. So we make this multiply. Let me go ahead and create a couple of print statements down here. So we say print, say addition of numbers. Then you go ahead and call that addition variable of ours. Then we go ahead and say subtraction. Subtraction of numbers, then we shall call the subtraction variable that we created. And this is the division of numbers. We shall go ahead and then call the division variable that we create up there, and then go ahead and say the multiplication. Yep. multiplication numbers, then we go ahead and then call the multiplication variable up there. So now if we run this, if we run Python, simple math.lib, you can see that hey, our program does what we expect it to do. Addition of numbers, 5 and 10 is 15, subtraction of numbers is 5, and of course when you divide 10 by 5 you get 2, and when you multiply 5 by 10 you get 50. So let's go on ahead and then do the other library. Now moving from unit test and going to this pytest tool, of course here they say you need to actually first of all install pytest using pip. Okay, and then the rest of the things are quite like really straightforward, like you're about to see. Okay, so when we come here, let's remove that. So as you can see, now let us first of all test our numbers. Let us test now. In order for us to when it comes to this py tool, it's quite easy to test actually. All you have to do is to import. You just have to import your module, which is in contrast to the unit test, where you have to first of all import the unit test and then you have to import your module. Here you only have to import your module, and you don't have to create a base class. You don't have to create the base class which has to subclass the unit test or test case. This is like out of the blue. Then I also mentioned that all tests must begin with a test. So this is how it actually knows that this is actually a test. So here we are now testing the add number, which of course takes in a first number and a second number. So as you can see, a couple of things are quite different. Here I have an assert equal, but here we only have assert. So assert equal is the same as just assert, and in this case you can actually equate. Here it's much more like English. You're asserting that the left hand is actually equal to the right hand. That is, if you assert that the method which is add numbers, when it is supplied to numbers like first number and second number, the result is 15. So in order to run this, all you have to do is quite simple. You have to say py.test. Py.test. Okay. Inconsistence of tabs and okay, cool. Let us first of all comment that out, and then we'll come back to our py.test. As you can see, we when you run py.test, it actually runs all the files that begin with the test, the test underscore and the name of anything. So what I did was to actually first of all comment out the code that we had wrote earlier for the unit test, because it was complaining about indentation and all that, which wasn't actually like true, because we saw it ran when we were running it. Anyway, so you have to just say py.test and it will look for all files that begin with the word test, and it will run all the tests that are in that, run all the test cases. Now you can also supply a -v to see more details. Now you can see here it says the test. Here it says test add number, which is found in a mathlib, in the test simple mathlib pytest.py passed, of course, at 100% coverage, because it is only one. So in the same manner, we can go ahead and we test our subtract number, and we go ahead and test also the divide number, not numbers. And then we also go ahead and we test the multiply number. So let's first clear that. So when you go ahead and execute py.test.v, here you see that it collected 4 test items and they all passed. Okay, so that was it for the first part of testing, unit testing, TDD. In the next module, we are going to go ahead and go deeper into this, because as you can see, we have first number, second number, first number, second number being repeated all over the place. Same thing here. Let's first uncomment this. Same thing here. You can see first number, last number, second number, first number. It's being repeated all over the place. And so unit test, this module here has a couple of methods. It has a method called setup, where you put things like this, which will be called each time before a test is run, and then it also has a tear down method, which is run after each test has run. So it does a little bit of cleaning up. And then for the pytest uses something else. It uses things called fixtures, which we shall talk about in our next module. Right now, have a good one.